our screen as the PowerPoint display?
Yes, yep, it all looks good. And one way to check that your audio will be working is the microphone in the lower left corner. As long as it's like showing green periodically, it should be good.
Perfect. So
it looks like we do have a student. I will.
Can they participants see how many participants?
I don't think so.
So I can be like, oh wow, there's a lot of people here.
Maybe they can. I'm not entirely sure.
Better. Shouldn't say
that. Yeah. Well, it would be great. Yeah, you're good to start whenever.
Okay, so welcome everyone to our virtual online open house for geotechnical engineering at the University of Washington, or as we call it here, the UW. I'm Brett Maurer. I'm one of the faculty, and I'm here with Mike Gomez, who is also one of the faculty in the geotechnical engineering group. And the idea behind this session is just to tell you quickly a little bit about our program, the courses we offer, what life would be like here, and then to give viewers an opportunity to ask questions. So what you're looking at here is an aerial view of where we sit. And if you're not familiar with the UW campus, we are in Moore Hall, very close to the Rainier Vista. So we've got a beautiful view of the mountain. And just 2 minutes from our building is the Husky Light Rail Station, which will get you to downtown Seattle in just a couple minutes, and really just about anywhere from there, including the airport. As I said, a little bit of life at UW. There's a lot going on. There's a lot to do. I think it's one of the things that makes our program quite unique is that we're in this really exciting environment. And as a student, you get what's called the U-Pass. So you can get on the light rail, the buses, the ferries, the train, anywhere for free. And I think what many of us here kind of appreciate about Seattle is just the diversity of what there is to do. I think whether you're kind of an urban person, you kind of appreciate the arts and culture and what it means to be in a city, or whether you like hiking in the mountains, it's all here. And we even have sandy beaches. So there are 5 geotechnical faculty, and then we also have 1 emeritus professor, Bob Holtz. He has written a famous book that you might be familiar with. And in addition, we have a lot of outside speakers, and we have guest instructors. As I said, we're in a big city. We have a really strong network of practitioners and alumni, and we really make the most out of our environment and that connection. So if you're watching this, you probably kind of already know what geotechnical engineering is all about. You know why you're considering it as a career. I think it's worth just kind of very quickly skipping through some of the things that you would learn to do if you do come to this program. What do the classes cover? One of those things is foundations. Everything is anchored to the ground. Everything needs a foundation. And in some cases, they have to be pretty innovative, as these pictures show. Retaining walls, they're everywhere. They're all around us. And in fact, one of the biggest mechanically stabilized earth walls in the world is here at the airport in Seattle. Tunneling, it's increasingly important, especially here in Seattle. We've got tunneling projects going just about all over the place as our train system expands. So there's a lot of really interesting tunneling to be seen right under our building, actually. Dams and levees, they're obviously really important to society and also really consequential when they fail, as you can see here from the Hurricane Katrina levee failures. All kinds of geohazards, landslides, soil liquefaction. It's all covered in a series of our courses. We have classes on soil dynamics and earthquake engineering, and I didn't mention this, but classes on each of the topics that we're looking at here. Reconnaissance, we tend to learn from failures, and so we include a lot of field trips and case histories in all of the classes we teach. Material properties, before you build with something, you have to characterize it. You have to know what its properties are, and so we have a course on lab testing. We have courses on instrumentation and field testing. Ground improvement. What do you do when your site is problematic? And so for example, that might be something pretty traditional. It might be something more innovative and cutting edge, like biocementation, which is one of Professor Gomez's expertises. We also have classes on numerical modeling, and I think there's an animation here. Yeah, so for example, if we turn over a bucket of soil and we can model how that would perform, then we can in turn start doing some more complicated things. Like we could model the impact of fluid and soil from a tsunami striking a bridge. What are the forces that exerts, for example? And we can keep going. There's a lot of things that we cover in our courses that we haven't mentioned. Building settlement, hazards, all kinds of environmental and biological and chemical issues pertaining to soils, ground motion prediction, and it keeps going. So this graphic is, I think, a couple of years old, but I recently saw that it's still true what it says, that we have more cranes in Seattle than any other city in the US. And that just speaks to kind of how much is happening here, and that there's always something interesting down the street. And there's a lot of really good alumni and practitioners to interact with, people that inevitably would try to recruit you to their companies. So case in point, this is a photo of the South Lake Union area in Seattle. And I suppose we don't see 60 cranes, but there's at least 20 of them labeled here. So probably every week, I would say, we have some kind of visiting lecturer from the community, alumni, faculty from other universities. I really just can't emphasize enough kind of how energetic this program is and how much there is to see and do between all the growth in Seattle and then also all of the hazards that we face being in an earthquake-prone mountainous region. So with that kind of summary of what life is like here and what you'd be exposed to through the coursework, we're going to switch over to talking about the degree programs a little bit, and Professor Gomez is going to pick up and kind of tell you what the classes and degree options look like.
Perfect, thank you. So we've got a couple of different options here, just to kind of briefly go as an overview of kind of the different graduate programs we have. First off, we have sort of a master's degree program, which within that you can have two options, which are going to result in sort of the same degree. In the first option, this is what we call our professional master's program. It's intended for people that are looking to move on to professional practice, and in this case, it's a coursework only based type of program, and so there's no thesis required. And the research master's program, this might be somebody who is also looking to go into professional practice, but may have interest in maybe thinking about doing research, either to consider maybe doing a PhD later on, or just having interest in research and wanting to do that at sort of the master's level. And so this would be typically something like a 1 to 2 year program. It generally requires a thesis being involved in that. And then the doctorate of philosophy, now we're talking about a much more extensive research program, and this could be anywhere from something like 5 to 6 years in total. And so we can kind of walk through a couple of these pieces, kind of focusing on the master's degree first. So again, like I mentioned before, these are the 2 different tracks. In either case, it's 42 credits overall. In the first case, this was our professional track. This is 42 credits being entirely of coursework. But it doesn't mean if you're doing the professional track necessarily that you can't be involved or active in some sort of research. There's also research experiences that you can do through independent study with faculty and talking to them, and maybe you have interest in their work. And so some of these things can replace elective credits as well, and basically still be within the professional track. In the research track, this is a little bit different. Instead of having the 42 credits of coursework, it's 33, and then 9 of those credits are actually replaced with thesis research. Here's a few kind of talking through the different credits. This is the first one is for the 42 credit coursework professional master's program. We have a variety of different courses in geotech, which we'll talk about in a bit, but we've sort of broken them out into sort of different requirements here. And so we have 4 courses which we feel are core courses that should be taken if you're going to graduate from our geotechnical graduate program. Those ones are advanced soil mechanics, slope stability, foundation engineering, and geological engineering. And then a variety of other courses are available. So there's an additional 24 credits rather that we offer. And from those, we allow you to take 19 credits from those, and you can kind of pick and choose from that list which ones interest you. In addition to that, in order to get to the 42 credit mark, you'd have 5 to 10 credits of electives. This could be in any department or program. It could be within CEE and sort of different groups other than geotech, or it could be in a different department altogether. In the research track here, this is again, the 4 core courses still apply. From the list of different courses, you'd be taking less than you would in the previous case, so only 15 to 20 credits from that list. In addition, you'd have 9 credits of what would be master's thesis research credits. So these are credits that basically go towards the fact that you're working on your research and you're spending time doing that instead. And then in addition to that, you have kind of the option to either have 0 or 5 credits of sort of outside electives. The PhD degree requirement is a little bit different. It's 90 credits overall, of which 30 of those credits would be coming from your master's degree. And so that would be sort of the first step towards a PhD. And then you'd need at least 18 course credits as well as 27 additional research credits. There's a series of exams just to make sure that you've sort of mastered some of the course material and concepts, and that a PhD is a good fit for you moving forward. And then I think that having research experience, or perhaps looking at master's research, or talking with a faculty member to kind of explore this option is probably the best approach if you're interested in something like this, which would be much more long-term and more research intensive. Here's a list of our geotechnical graduate courses, just kind of marching through all of the different offerings that we have. The main thing to kind of think about here is that we've got 11 courses, and really we've sort of staged our courses to move from much more fundamentals to more kind of practical application based. So in the beginning, you're going to be learning about advanced soil mechanics and theory, maybe looking at some chemical and biological processes and microscale phenomenon in soil, as well as lab testing. In winter, you'd be doing soil dynamics, as well as slope stability and landslide, computational geomechanics, and case histories. And then towards the end, you're doing things like geotechnical earthquake engineering, geosystems engineering, and advanced foundation design, where you're really kind of applying all the fundamentals that you've learned in the previous 2 quarters. This is one example of sort of a 9-month professional master's degree plan that could be done to get to 42 credits. We're talking about something between 12 and 15 credits per quarter. This is just one potential option to give you an idea of how many courses you might be taking per quarter. Of course, if you haven't had undergraduate soil foundations design before, then in autumn, we also offer that, and this could fulfill some of your electives and would be a required course so that you could take advanced foundations later on in the spring. We've also got a variety of different graduate elective courses. As I mentioned before, it could be anywhere from 0 to 10 credits that you might need for a master's program. This could be looking at different things within civil engineering itself, such as remote sensing and a variety of other topics that might work well with your interests in geotechnical engineering. And then we also have a variety of other great departments throughout the UW, including classes in earth and space sciences, geology, and a variety of other different topics that you may find of interest, and really great programs, and the ability to be here and access those is really great. And in addition to that, as we mentioned before, there's also the ability to do some independent research study or credits as well, and that can fulfill part of those elective requirements too. So here's kind of just a graph to talk a little bit about how long it might take to complete a master's degree here. I would say probably the majority of the students that come through this program want to do something in 9 months. Maybe they're looking to work in industry within the next year or so. And so I would say there's greater than half of those students that are able to actually complete the 42 credit program in 9 months. There may be another fraction of those students, maybe 15% or so, are looking at a 12-month type of program wherein they might take 3 quarters an additional quarter the next year. And as a result of that, they're able to take less course loads throughout the entire year. There's other programs would be more looking at sort of the thesis type of program, or perhaps someone that wants to study abroad in Scandinavia through the Valet program. In this case, it might take something like 1 to 2 years. And then there are a fraction of students that also take longer than that. And that is that they might be working full time. And so they're taking a couple classes per quarter, and they're slowly working through the degree program that way. And I think in either case, it's always a personal decision on kind of what fits for you, but there's a variety of different options to accommodate those different timelines. In terms of our graduate program, we've got typically in a given year, we've got about 20 to 25 different students. I think one of the strong points of our group is that it's a really diverse group, people from a lot of different places and backgrounds, so that's always great. In terms of different student activities, we have GIGS, which is our geotechnical student group. And they organize different variety of different seminars and field trips, as well as social activities such as Geo Beers, wherein the faculty and the students can go out and hang out and chat and socialize. There's a variety of other ASCE sort of monthly dinner meetings that we have a pretty strong presence at. And then GIGS has sort of honored lectures. One of those is sort of the Hennis Lecture, wherein we'll invite somebody who's really a leader in geotechnical engineering. They'll come and give a presentation. We'll be able to meet with them. And a variety of other activities throughout the year. But I think it's a really active, a really exciting, and a really great group to be a part of. This is just one example of kind of one of those events that we do. This is the Pacific Northwest Graduate Student Symposium, where we've got people from a variety of different universities, OSU, Portland State, UBC, all located in the Pacific Northwest, and a variety of other universities as well. They come either here or a different campus, and we try to organize this on something like a 2-year basis. The idea is for graduate students and at these different universities both to share their research and their experience and sort of kind of form a more cohesive community together. We've also got a variety of other types of outreach events. This is one example, Engineering Discovery Days, which happens in the spring. And so it's an opportunity for our graduate students to share their research with K-12 students that come here wanting to learn about what engineering is. And so they're able to teach them a variety of different things about geotechnical engineering, why it's important, and get them excited to be thinking about a career in STEM or even becoming a geotech someday. So that's always a fun event. We've also got a variety of other potlucks and different things that we do throughout the year. This is autumn 2017 at Professor Arduino's house. It's always a great time, and it's a lot of fun to hang out together. Now, just talking a little bit about our different facilities that we have. This is sort of our standard graduate lab. We have a variety of different instrumentation to do different tests, including soil classification, permeability, soil strength testing. So we've got triaxial testing devices, as well as a new direct simple shear device as well. And so these are all the types of things that you would be doing in the advanced geotechnical laboratory course, We've also included a variety of new things in kind of the upcoming years. This year, they are doing X-ray CT scanning and they're doing geophysical measurements. So it's kind of a lab class that's always sort of trying to adapt and trying to look at new technologies and teach you about them and give you experience with those new methods. We also have at kind of the research side of things, a variety of other types of specialized equipment, including a true triaxial or cubic triaxial device, as well as a resonant column device, a ring shear, and a variety of other very specialized equipment, really kind of tailored towards the research side of things, but certainly accessible and around and available to explore different things. We've also had kind of a recent renovation of our laboratory facilities, kind of the research side, including having a variety of different field and lab shear wave velocity measurement systems, as well as DSS and kind of multi-testing machines, both in triax and consolidation as well. One of the most or more exciting things that we have going on the research side is really the Rapid NEARI facility, which is located here. So this is a national facility through the NEARI network, which allows Professor Wortman, who's sort of the lead on this, as well as a variety of other researchers here at the UW, to basically have a variety or a suite of equipment that they can deploy to disaster zones after they occur. And the intention is to collect perishable data that wouldn't be available, let's say, years from then. And so they deploy these different pieces of equipment, drones, LiDAR scanners, and a variety of different things to sort of explore and learn from these disasters moving forward. So this is a unique facility that serves the whole United States, and we're lucky enough to have that here and some interesting research projects and groups that come through here as a result of that. So with that, I think we'd be willing to open it up to questions if there are any, and thanks for your attention.
Yeah, so if you do have questions, I think you can type them in. It looks like we already have some that have come in during the presentation. So we might start with some, but if you've got some to add, please do send them in.
One question that gets asked a lot is where do students get jobs? And it seems that a lot of them end up staying in the region, but you all probably have pretty good connections with employers. Like, where is there a specific type of work most students end up doing?
Yeah, that's a great question. And it would be hard to identify just one type of job because we send students to consulting, to academia, to government, on to other sort of science institutions. There's really no one place that people end up. I mentioned that we have a really strong network, though, of alumni, and they undoubtedly try to recruit students. That doesn't have to be in Seattle. These are companies that have a national presence, but with offices here. And so you'll definitely have many opportunities to network and to get to know these professionals. And regardless of what city or what country even you aspire to be in, I think you will definitely find connections back to UW that will help you find a job.
Great. In terms of timeline, you said that 3 quarters is kind of a common pace. But in terms of sequence of classes, is there anything that a student should be aware of if they're planning on doing a kind of more part-time or extended program? In terms of like which courses would you want to make sure you take first in terms of stacking it? Because you said it kind of went from like more practical to applied. I can't remember, or theoretical to applied. Does that make sense?
Yeah, no, I think that's a great question. So I think we've set it up so that the program can be done in 9 months. But if a student would like to take a longer period of time, that's totally doable and is understandable. And I think that there are certain prerequisite courses that are really important to have. One of those being, let's say, in fall, advanced soil mechanics, as well as maybe the lab course as well. And then there's some that kind of come together. That is, soil dynamics and geotechnical earthquake engineering have a really good synergy together. And so you'd probably want to take soil dynamics before you take geotechnical earthquake engineering. just like you would want to take undergraduate foundations before taking the advanced foundations course. So I think there are some dependencies between the courses. Really, if you're able to take the courses in the beginning, these are sort of the fundamental. These are going to provide you with the principles. And then moving on to winter and spring, sort of on a case-by-case basis, I would say more or less those are applying the principles that you would learn in autumn. And so it's kind of sequenced in this way. I don't know if Brett, if there's anything you wanted to add about that.
I would just add that there's no right way to do it. We always have people who are trying to do it very quickly and people who are doing it over the course of years. Maybe they're working part or full time as they attend school. And you also don't have to know when you arrive what your timeline will be. We generally encourage people to take a set of courses in their first quarter that might allow them to finish in 9 months. But you're the best judge of what is best for you and what you're happiest doing, and that's important. And so at the end of the first quarter, it's still very easy to choose what your timeline will be.
Yeah, and I think it might be helpful also to add is, so every student who comes into the program has 2 advisors. They'll have one that they work with for kind of the more administrative side of things, making sure you're hitting all the requirements, but every student has a assigned faculty advisor who's kind of their subject area expert. And it seems like kind of what you're saying, you can kind of make an individualized plan based on what the student's goals are and what they really want to get and what their timeline is. So you do have some guidance. You don't have to figure it all out how everything stacks, but it's good to know that you're there to help. Another pretty common question that we get is students who are interested in doing a PhD, and if they want to do a PhD, do they need to have a master's first? What kind of research experience are you looking for to make them a competitive applicant? Are there specific things that come to mind for you?
Yeah, well, that might be the kind of question where you get a range of responses depending on who you ask and what they think is best. I don't think there's one single right way to do it or list of requirements. It's not necessary to have master's research to do a PhD, but it's probably best that you do. It's best for you because before you invest 4 years or more on something, it's good to know that it's what you want to do. And you can only figure that out through some previous experience. And so when we have master's students that expressed interest in the PhD, even if they don't choose to do the research track master's, we like for them to do independent study research or whatever they can to see if it's a good fit for them, if they enjoy it. And then it also helps the faculty certainly to gauge the students if they have some previous research. And so I think most PhD students do have research coming in, but it's not necessarily required. And it isn't like there's some list of prerequisites or number of posters or papers you have to write. Do you have anything to add?
No, I think that is a good representation. I mean, I think it's really depending on the faculty that you talk to. I think I would share the same thought that it really is helpful to have a sense of whether or not research is for you. Research can be very different than coursework, and so I think at least in terms of my group as well, having people at the master's level kind of getting a taste for it, seeing if research is for you, both for our side and for your side, to just kind of see if you like doing that, is always really helpful. And sort of the research master's timeframe is 1 to 2 years. It's very doable. And then after that, you have a good understanding of, well, first, if you're interested in the research, if you like research in general, and kind of what maybe the next couple years would look like if you were to stay around. And so that's certainly not required. You could come in with a master's and be accepted as a PhD student. That's not off the table at all. But I do think it is, if you have kind of an interest in research, expressing that to one of us and letting us kind of know what your goals and thoughts might be about that could be a good starting point to kind of get the ball rolling and start thinking about whether or not a PhD track could be possible, both from sort of a funding side, but also from an interest and faculty compatibility standpoint too, I would say.
Do you want to give a quick overview of like what your specific research is in and what your interests are? If you think that would be helpful.
Yeah, I think we cover a pretty broad spectrum. Personally, I focus mostly on earthquake engineering problems. So developing models to predict liquefaction would be one example of something I work a lot on. We also have Professor Steve Kramer, who is one of the world's experts on earthquake engineering. Professor Pedro Arduino is an expert on computational and numerical modeling and lab testing. Professor Joe Wortman, as was mentioned, he is heading up what's known as the RAPID facility, which is this national research center focused on reconnaissance after disasters, floods, earthquakes, tsunamis, any kind of disaster would fall in the realm of his research. And I will let Professor Gomez speak for himself.
Yeah, so my research is kind of in a new field of what we're talking about called bio-mediated kind of technologies or geotechnics. And so my research really looks at using chemical or biological processes in soils in order to improve them. And one example of that might be mineral precipitation. So precipitating out things like calcite in the ground to stabilize them, to prevent them from liquefying during earthquake-induced ground motions, and a variety of different other types of loading. And so we do a variety of different lab testing, as well as kind of interdisciplinary microbiological and chemical type of measurements as well in that.
Great, thanks. Are there any final questions in the chat? If not, we can start to wrap up. If you have any further questions, a good email address to always keep in mind is the CEG info, which is CEGINFO at uw.edu, which is monitored by our grad advising team. They're a good place to relay your questions if they can't answer them to the geotech experts in our department. But they have a lot of the answers for kind of more procedural questions. Keep in mind the admissions deadline is coming up in December 15th. If you have questions, feel free to reach out. Otherwise, thanks for joining us today. Any last things you two would like to add?
No, just that if you joined late, which I see some people have, and you missed anything, the full session will be posted on our department's website pretty soon. So you can catch it there. And thanks for joining.
Thank you.